Hello everyone and welcome to ixamBee. So in this video we are going to discuss about the concept of coupling and cohesion, and this particular concept is under the topic of software engineering concept. So this is the part 2 of our video. If you want to watch part 1, then you can go to our channel or you can find the link directly in the description and can watch the part 1 as well to get some software engineering concepts. So basically these concepts are important for all the IT aspirants who are going to appear either in NABARD or in IBPS or in RRB. So these particular concepts are very important for majority of the IT aspirants in the government examination. So we will begin our discussion, and the discussion will start with the SDLC. So SDLC stands for Software Development Life Cycle. Okay, so software or system development life cycle, it is actually a process in which there are several steps. So this particular step starts from the stage of the requirement analysis, then it will go to design, then implementation, testing, and the evolution, or you can say the maintenance. So whenever a software is developed, it has been put through so many steps, and these steps are being totally accumulated together in the SDLC models. So there are so many different SDLC models, but more or less the steps are actually the same. The type of techniques that they involved are different, but the actual soul of every SDLC model is exactly the same, which involves these all steps which I have shown here in the circular format. Okay, so here we are going to learn about the coupling and cohesion. So in coupling and cohesion, the major thing that we have to deal is with the designing part. So design part is very important. So we will limit our discussion to the design part only for the video. Okay, here the purpose of the design phase is to develop a solution to a problem, okay, which is given in SRS. SRS stands for Software Requirement Specification. Okay, so whenever there is a requirement, that requirement will be actually codified into a document, and that document is called as SRS, where all the requirements specific to the software are listed. So looking up to that particular SRS document, we design our system. Okay, and the output of this particular phase is our design document. So after we complete our designing, so the input for the implementation state will be the SDD, that is the software design document. So in this particular thing, we have to do a lot of calculations, we have to brainstorm ourselves in order to understand what need to be done in the design phase. So there are several concepts in the design phase. Some of them are like, in the design phase there are basically two kinds of design. One is the conceptual design and one is the technical design. So in the conceptual design, what we do, we tell the customer what the system will do. Okay, whenever we will have the requirements of the customers with us and we design our system. Okay, after designing our system, if we design it with a conceptual design, then we will tell the customer what exactly the system will do. If you will provide this much output, what output you will get, what system is efficient of doing so. So it is a conceptual level thing. Then we have the technical design. Under the technical design, we will give all the technical details so that the system builders who have to actually build the system in the implementation state will understand the hardware and software requirements. Okay, and these hardware and software requirements are always in line with the understanding of the SRS document that is provided as the input to the design system. So in design, we have two things. One is the conceptual and one is the technical. The conceptual one is from the point of view of the customer, and the technical one is the point of view of the implementations, or you can say the system builders, or you can say the software system. The next concept is like the conceptual design of the system. These are the major features. The major features are like, these are written in a very simple language to understand. Then a detailed explanation about every feature, what the system is going to do. It will describe the functionality of the system. It will be independent of the implementation. Whatever the conceptual designs we play here or we portray here, that are actually independent totally of the implementation. They do not have to deal anything with the implementation. If our conceptual design changes, implementation might not be affected. Okay, then it are requirements with the document. Okay, so it is linked with the requirement document. Next one is the technical design. So next technical design is like it is the hardware component and the design system, and here the functionality and hierarchy of the software components are more or less concerned. Software architecture, network architecture, and the input output system, and the data structure and the flow of the data. So you can see these all entire parts are related to the software component, that too with the technical design. So this will directly affect the implementation. Okay. Next concept is like the modularization. So modularization is very important concept. In modularization, what we do, we actually divide a software system into multiple independent modules. What we do, we divide a software into multiple independent modules where each module work independently. So when we divide them independently, these modules are supposed to work independently. Okay, why we do this? We do this to maintain the system in an easy manner, so that the system maintenance get easy for us. Also, whenever we want to reuse a particular module, when there are very much overlapping requirement, we can use that particular module. We don't need to write it again and again. So a module will be reusable as well. Till the time it is more of the less independent, it will be very much reusable to us. Then it is very easy to understand with the system. When there are modular system, if I give you 1 lakh piece of code, that will be very difficult for you to understand. But if I break that particular code into say 1000 codes of 100 line each, then that will be very easy for you to understand. You can finish it off module by module and you will understand the whole system. So the understanding of the system is also increased, reusability factor is increased, and the maintenance automatically get increased. After that thing, the main concept of today's video is the coupling. So coupling is what? Coupling is a measure of the degree of interdependence between the modules. So one module say M1 and there is some other module say M2. So how much these are interdependent on each other, how much they are actually dependent on each other, how much degree of interdependence they share with each other. For that particular measure, we do the coupling. Okay. So a good software will have low coupling. It means the interdependence of the software, if it is very low, then our software will be good. Why we need a low coupling? Because if my software modules are very much interdependent on each other, and if one of the module is not giving the correct output, or if one of the module fails, then it will affect lot many modules. So the entire software will hamper. Here, if we have a low coupling thing, that means that the system will not be that much hampered. See, whenever there is a software, whenever there are modules, there is some level of interdependence. Okay, so they are actually dependent on each other, but the degree up to which they are dependent on each other, that can be controlled. So if you want to make a good software, just make sure that you have a low coupling. This point is very important. Just mug it up that for a particular software to behave as a good software, we should have low coupling. Okay, so there are range of couplings. Range of coupling means these all types of coupling we have. We start from the uncoupled, means there is no connection between any modules. Okay, so if we have a software where no modules is connected to any particular module, that particular software will be called as have low coupling, or you can say that this particular software is having the uncoupled nature. Then we have the data, stamp, control, common, and the content. As we move from downward to upward, the coupling increases. Okay, so if I ask you that which of the particular coupling is better, either the common coupling or the stamp coupling, so you will say that a stamp coupling is better because it is of a low coupling environment and the degree of interdependence will be low. So to make a good software, if we have two options to choose from, that is common and stamp, we will go with the stamp coupling. Okay, so this particular hierarchy you have to learn. There might be a question which will ask that which particular coupling methodology is the best one to develop a software. So there you have to keep in mind this hierarchy and you have to answer in that particular phase only. After that thing, let us learn about each coupling in very much detail. So the first coupling that we are discussing here is the data coupling. So what data coupling? Here the dependency between the modules is based on the fact that they communicate passing only the data. Okay, so what it is actually being done in data coupling, all the components are basically interdependent to each other and they only communicate via data. If you need any data, I will give you any data, but my functioning is not affected by that data. Okay, the internal functioning, all the data that I have, that won't be get affected. The only communication that we are going to do is in the form of the data. That is the only passing of the data. For an example, here is an example of a student library and the book. So student will ask whether a book is available. Then the librarian will check into the books that it is available. If it is available, then it will provide the book and the student will reserve the book. So in this particular whole scenario, the student module is different, librarian module is different, and the book database is different. Here all the three modules are only communicating by the means of the data. Okay, so this particular example will be called off as data coupling. The next example is of the stamp coupling. So here the complete data structure is passed off from one module to another. So what happens? Earlier we see that there was only data that was getting passed from one module to another module. But here the entire data structure will get passed. When I say data structure will be passed, there are so many data structure that are predefined, that are user defined. So whatever the data structure of a particular module is there, interdependency is in that manner that we need to share this data structure between the records of module 1 to records of module 2. So whenever there is a complete data structure that is passed from one module to another module, that comes under the stamp coupling. The next one is of the control coupling. So control coupling, here the module communicate by passing the control information. It means they are controlly coupled. One module can direct the other module to function. Okay, it means very high level of interdependence is there. One module is looking for the control instructions to be given by the second module. Okay, suppose we want the sort function that takes the function as an argument. So here whatever the functions we are taking in the argument are actually the information, controlling information that will say that how this sort function will be working. Okay, so here control informations basically are passed from module 1 to module 2 or vice versa. Then we have the common coupling. So in common coupling, we know that there are some data which are shared globally and there are some data which are shared locally. So these modules which are having the common coupling share that particular piece of code which are defined as a global data structure. So a global data structure will be accessible throughout the software. Okay. If that particular global data structures is being shared, then we are saying that, okay, this is a common coupling scenario. Here in the changes in the any global data system or in a global data structure means all the modules which are accessing that data will have to evaluate the delta changes if we change that particular common module of the global data structure. It means if the global is hampered, all the modules which are interdependent on that will get hampered. So you can see there is a very high level of coupling, or you can say very high level of degree of interdependence between these two. Okay, so we are landing into a disadvantageous situation where if we want to reuse the module, the capability to reuse the module is actually low because the ability to control the data is reduced. Okay, and so forth, we will land up into the maintainability reduction. Okay, so whenever there are global data structures defined, we have to make sure that these are those which will rarely change. Because if these changes, then all the other modules which are interdependent on that particular thing will actually have to evaluate the delta effects of the change that happens with the global data structure. So this particular kind of coupling is a very high coupling which is actually not promoted for a good software. Then there is the content coupling. So what do we mean by content coupling? In content coupling, one module can modify the data of another module when the control is passed from one module to another module. So this is the worst kind of coupling and it should definitely be avoided. Why? Whenever there is a module, if we try to calculate or we try to evaluate or we try to control that particular module with the help of some other module, it means that particular module is not having any importance of itself own. Okay, it will be controlled by the other particular module. In that particular sense, the degree of interdependence is reaching up to a certain extent where one module is inferior and the other module is superior. So in that case, why to have these two different? Just make them into one so that the content coupling will be reduced. So whenever there is a content modification from one module to another module, when the control is passed, so we have to make sure we should avoid these situations if we can. Okay, there will be some situation where we cannot do so, but if we want to reduce it, it will be very best to reduce. Okay, so this is the worst form of coupling and it should definitely be avoided. After the concept of coupling, we will land up to the concept of the cohesion. So in cohesion is also a measure of degree to which the element of the modules are functionally related. See, coupling was there. Coupling was checking the degree of the interdependence between the modules. But here, we are checking the degree to which the element of the modules are functionally related. What are the elements of the modules that are functionally related to each other? Okay, so it is the degree to which all the elements directly put their efforts together to perform a particular task. So here different modules will come together. They will have a same agenda and they will perform a single particular task that are contained within the component. So basically cohesion is good because several modules are coming together and to perform a single task. Okay. Here the cohesion is acting as a glue which will keep the modules together. So a good software design will have high cohesion. It means like a teamwork. Whenever a lot of teams are coming together to achieve a particular target, that will be very good. Okay, so we need to bind them all together, and to bind them all together we need some element that are functionally related throughout those modules. So in order to have a good software, we should have high cohesion as well as low coupling. So this thing you have to remember: low coupling and high cohesion. These are the actual thing for a good software. Okay. Let's move on to the types of module cohesions. So these are the module cohesions. So the way the modules are actually talking to each other, the more stronger the glue that connect to them is present, we will say that particular cohesion is the best cohesion. Okay, so there is the range. When we move from downward to upward, the connectivity between the modules is actually increased. They will come together to perform a single task. So that will be the best cohesion. Okay, so there are functional cohesion, sequential, communication, procedural, temporal, logical, and the coincidental. Okay, so these are the type of cohesions. Let's discuss them one by one. So first of all, functional cohesion. So functional cohesions are very much essential. As you can see, functional cohesions are on the top of the particular hierarchy that we see just a slide before. Here you can see functional cohesion is at the top. It means it will be the best particular thing for the computational component. Okay, so a functional cohesion performs the task and functions, and it is an ideal situation. Here the essential, very essential element for a single computation is contained in the component. Okay, so this is very important. The functional level cohesions, the functional level interdependency of the key elements. Then the sequential cohesion. In sequential cohesion, an element outputs some data that becomes the input for another data. What it means, when we have a data flow between different parts. Suppose these particular modules are present and these particular modules work in a sequential manner. When I say sequential manner, I mean that I need to get some particular module done in order to proceed for some other module. Some particular module should get the work done, then I can proceed with the other modules. In the same manner, the flow is said to be in a data flow, like this will be done, then this will be the input of this thing. Okay, so the output of this thing will be the input of this thing, and the same goes on. Okay, whenever this kind of cohesion is present, that is also very good thing, because whatever the output is calculated by the previous modules, that input is taken carry forwarded, so no one has to do the rework again. So this particular cohesion is also a very good cohesion. After that, communication cohesion. Here the two elements operate on the same input and contribute toward the same output. It means there is a common space, or you can say there is a common variable. That particular common variable is actually accessed by two or more than two modules, and this particular thing will be actually modified by all these modules. So here the communication cohesion is there. It means if one particular module will modify the value of any one of the common variable, the other particular module will also get the updated value, not the previous value. So every particular module will stay updated. Okay. After that thing, we have the procedural cohesion. So in procedural cohesion, elements of the procedural cohesion ensure that the order of the execution is followed. So if we want to have a particular order, not essentially the sequential, because that is itself a different type of cohesion. If you want to follow a particular procedure, okay, in that particular thing, we have to define the rules and the regulations that are to be followed for the order of execution. Okay, so here this particular thing defines the order of the procedure, and this is actually not that great. Okay, so actions are still weakly connected and unlikely to be reusable because there is set defined procedure. So that particular thing will not be reusable if there is another change in the scenario. Okay, for an example, the calculation of the percentage or the CGPA or the GPA of a particular thing. So first you have to calculate, then you have to print, then you have to calculate, and then you have to print the cumulative mark. So there is a procedure, set defined procedure. You cannot interlink them in a random order that I will print the first before calculation. This is not possible. So a procedure is being set. You can see these are very weakly connected. If one gets lost, the other one is like of no use then. So no reusability factor is present. After that thing, we have the temporal cohesion. So in temporal cohesion, things are likely to get involved in the time basis. So temporal means timely related thing. So whenever there is a time span, the task must be executed within that time span. Okay, so here the cohesion code for the code of initializing all part of the system is present. So whenever we initiate a particular software, that particular software will have some code of the initialization. So that particular thing is actually the thing where every module with a temporal cohesion, all the tasks should be executed in that particular time span, and for doing that thing there will be a code area where all the modules will be initialized as the part of the system. Okay, so timely basis is involved here. Okay, then the logical cohesion. Logical cohesion says that elements are logically related, not functionally. We know that okay, this particular thing and this particular thing will have a logical relationship, but actually that is not implemented in the code. So actually the codes are very much independent. Okay, they are not functionally related, but anyhow they are logically related because they are working for the same component. After that thing, we have coincidental cohesion. So in coincidental cohesion, the elements are not related. They are totally unrelated. They don't want to either get logically related or get functionally related. These elements have no conceptual relationship, or you can say the technical relationship within the module itself. They just share a common source code. We have a software, there are two modules which are totally unrelated to each other, but they belong to the same source code, same software package. In that particular cohesion, there is only one glue, that is the software source code, which are keeping them together, but no logical or functional cohesion is present. Okay, so this is the worst form of cohesion that we should actually avoid. Okay, so these all were the type of the cohesion that we read, and I hope you understand the concept of the cohesion. So let's see this particular chart again. Here we can see the coincidental cohesion is of the lowest to worst kind of cohesion, and the functional one is the best one. Okay, so this particular order is very important. This can also come in the form of the MCQ. So by this thing we get to the end of our video. Here we learned about the SDLC design concepts, then what is actually the modularity, then the cohesion and the coupling. Okay, so now you can revise these important concepts. If you like this video and understood all the topics completely, you can like and subscribe to the channel and press the bell icon. Also, if you find this video informative enough, then do share it with the other people outside to have the knowledge with them also. So this was a video on the coupling and cohesion concept of software engineering module. We will come with some more videos related to the software engineering concepts to make you better understand for your preparation. For that time, stay updated and keep practicing.